Today we'll see very interesting problem. We need to prove that square of an odd number in the form of 6q plus 1 and 6q plus 3. We can express in these two format like that we need to prove, okay? So what is an odd number which is not divided with the 2, right? So I write the positive odd numbers like, right? You see 1, 3, 5, 7, so on, so right? So the general form of the odd number can be written like 2k plus 1 format, okay? So here if k is equal to 0, what happened? This 2k, if I put k 0 here, so it will come like 1, right? The number will come 1. K is equal to 1, we'll get the number like 1 into 2 plus 1, right? That is a 3. Like that you will get all the odd numbers if you keep varying the k, okay? So in the general form of the odd number can be written like 2k plus 1, okay? So the square of an odd number is always an odd number. That we can prove very easily like this. 2k plus 1 is an odd number. If you make it square of an odd number, okay, we can express like this is 4k square, a square plus b square plus 2ab. If you write it, we will get this expression, okay? So if you take here 2 common here, it will come like 2k square plus here 2k plus 1, right? So here 2k square plus 2k, if you write it in something like another k, this in the format of some 2k1 plus 1, right? Some another k1, okay, for the entire expression. So the square of an odd number is also a odd number, okay? Now we need to write the square of an odd number in the form of 6q plus 1. Means what we have to do is, right, I will just say that, for example, 10, you are dividing with the number 3, okay? So how do you do? 3 3s are 9. If you subtract 10 minus 9, it's a 1, right? So that the 10 number can be expressed like 3 into 3 plus remainder 1, okay? So this way you can express any number, okay? Take any number, x is the odd number, okay? Let's take the x is the odd number, okay? So now you are dividing this x number with 6, okay? Then you multiply 6 into q times you are multiplying, okay? So that you are getting 6q here, okay? Then the remainder you are getting something like, let's take the r as the remainder, okay? How you can express the x number always then? The x number you can express like 6q plus remainder, right? Isn't it? So x is equal to 6q plus r, right? So how the remainder will be there? Remainder cannot be greater than the 6 always. If it's greater than 6, again we will go to the q, 6 into q plus 1 times, and remainder will get like 1 or like that, okay? So the remainder always lesser than 6, okay? Or lesser than is between the 0 to 6, right? 0 is perfectly divisible, and we may get the remainder either or can be 0, 1, 2, 3, 4 or 5, right? Cannot be 6, the remainder, okay? Why I did with 6 only, right? We need to prove it with 6q plus 1 format, right? That's why I divided with 6, okay? It's nothing new, okay, in that. Okay, now we get these are the remainders. Now let's see. If you substitute the r is equal to 0 here, then what will happen? X, okay? X will become 6q, okay? It's the even number, right? Not the odd number. They say that x is the odd number, okay? If it's the odd number, okay, 6q is not the odd number. Why is not number? If you write any number in the format into 2k, okay, it is a even number, you know, right? So if k is equal to 0 means 0, k is equal to 1 means 2, k is equal to 2 means it's a 4. Like that you will get the all even numbers only you will get, okay? If you write any number in the form of 2k, if it is x is equal to 6q, this can be written like 2 into 3q, right? So it's a 2k format. So it's even number. So we need to take only the odd numbers, right? Only the odd square of an odd number can be expressed in the format in this, right? Right? So that this number will be removed, okay? Next, we will take the r is equal to 1, okay? Then what happened? X is equal to 6q plus 1, right? So this is definitely odd number. We will take this number, right? When r is equal to 2, okay? X is equal to 6q plus 2. Okay, if you take 2 common here, 2, it would become like 3q plus 1, right? So again, it is written in the form of 2 into some k format, right? So this is the even number. So we'll reject r is equal to 2 also. R is equal to 0 also we reject it. Similarly, r is equal to 3 if we put it, okay? So we get it x is equal to 6q plus 3. This is also odd number. Let's keep this, okay? So next r is equal to 4. So x is equal to 6q plus 4. Here also can take 2 common. So this is also even number. So this number also we reject, okay? Next, last number r is equal to 5. If you put it r is equal to 5, you get the x is equal to 6q plus 5. Okay. Now, this is the again odd number. So, the possibilities, I will erase this one. So the x possibilities of odd numbers for the x is right. So x is possibility odd numbers are can be written like 6q plus 1 and 6q plus 3 and 6q plus 5, right? So only these 3 options is there, okay? So that any odd number can be expressed, any odd number can be expressed in the form of 6q plus 1, 6q plus 3 and 6q plus 5. But we need to prove that square of this odd number we can write in the form of only 6q plus 1 and 6q plus 3. Okay. Now all the 3 terms we will do the square and we'll see. Okay. So that we am doing like x square. Okay. The first term I am doing. Okay. That is a 6q plus 1. Okay. Square I am doing. Okay. So what is square if you do here? So 36 q square plus 1 plus 12 q, right? Okay. So if you take common here, 6 here, okay, 6 if you take common here, this can be written 6q square plus 2q plus 1. Okay. If you write this entire term as another q, okay, there is a new q, like q1 like that. So this is in the form of 6q plus 1 can write, okay. So the first term, square of the term, right, it can be expressed like 6q plus 1, okay. Now we do x square for this 6q plus 3, okay. 6q plus 3 square I am doing, okay. So what happens? It is 36q square plus 9 plus 36 again. 36 into q, okay. So 36q square. So here 36q, okay. This 9 can be written like 6 plus 3, right? 6 plus is the 9. If you take common out of all these 6 number, okay. Then if you take common 6 number here, so it will become like 6q square plus 6q plus 1 again plus 3, right? So this entire term now, if you take it as another variable like q, right, this can be expressed like 6q plus 3. Okay. Now we'll check with the last term, okay. If this is also we are able to write either 6q plus 1 or 6q plus 3, we are done with the problem, okay. Now let's check with x square the last term. Okay, that is 6q plus 5 whole square, okay. So now if you square it, 6q square is 36 square, 5 square is 25 plus 2 into 5, 10, 10 into 6 like 60 q, okay. Now 36 q square will go with 6, no problem, and 60 plus q will go, no problem, okay. Plus this 25 can be written like 24 plus 1, okay. Then if you take common 6 here, okay, then what will come here? 6q square, okay, this is a 10q, okay, and 6 4s are 24 plus 1, okay. So now this entire in the bracket term can be expressed like another q variable, so it will become like 6q plus 1 format, okay. So what we check, right, if you take any odd number, okay, if x is the odd number and we divide with the 6, okay, so we are eliminated the whatever the even number possibilities of the x, okay, we are keeping the only odd possibility of the x number, and we are getting the remainders, okay, with the remainder either 1, 3, 5, okay, we'll get that way. So the positive remainders like 0, 2, 4 are the even numbers, so that we are eliminated those numbers. So these are the odd numbers, okay. Then if you find the square of the odd numbers, right, so any of this square of the odd number, right, can be expressed like only 6q plus 1 or 6q plus 3, okay. Even this also we are getting in the form of 6q plus 1 only. So that is the final answer for the problem. Okay, thank you. If you like the video, share it with your friends and subscribe to my channel. Thank you all.